Okay, everybody seems to know how to derive the equations of uniformly accelerated motion and use them. I've seen everybody do this. Okay? So you can plug things into the equations of uniformly accelerated motion. But right now, when I pose this simple question related to a car moving across a tabletop, okay? If the car starts at 30 centimeters per second, and the acceleration is about negative 20 centimeters per second squared, what can you immediately conclude? Well, someone finally concluded that it should stop in 1.5 seconds. What does acceleration mean? This means negative 20 centimeters per second. Now, why is it important to understand this? Well, this tells your velocity changes at negative 20 centimeters per second every second. Okay? Now, if your velocity is changing at negative 20 centimeters per second, and you start at 30 centimeters per second, what do you conclude? Well, after 1 second, the velocity will have changed by negative 20 centimeters per second, right? Okay? So starting at 30 centimeters per second, after 1 second, the velocity will have changed by negative 20 centimeters per second. And what's the velocity going to be then after 1 second?
10 centimeters per second.
Okay? Now, we know that this is a car being slowed down by friction, right? And we know that once the car stops, friction is not going to continue accelerating it, right, in the opposite direction. Okay? So knowing the nature of the force, we know that the thing is going to eventually come to stop, and it's not going to be moving again unless something else intervenes, right? Okay? So this acceleration, we'll just, this acceleration is due to friction. Okay? And this is a car on the tabletop. Okay, well, when is it going to finally come to rest? Well, if it goes for another second, what's going to happen?
It's going to be at rest.
Its velocity is going to be negative.
Yeah, well, if the acceleration remained negative 20 centimeters per second squared after another second, it would lose another 20 centimeters per second, right? And it would be at negative 10 centimeters per second. But we know friction won't do that. Okay? If you were to change direction, friction would change direction. And you can conclude very easily that that isn't going to happen. Okay? Make sense? So, what do you conclude happens?